Hello geometry students and welcome to lesson 6.3. Today we're going to talk about the properties of parallelograms. So what I'm going to do is I'm going to draw a parallelogram by taking a triangle. I've duplicated it and I'm going to bring it over here and rotate it and then slide it back over. Okay, to piece it together this way. So since the triangle is duplicated, I know that this angle is congruent to this angle. And these angles are alternate interiors. And when I have congruent alternate interiors, then I know this side is congruent to this, or parallel to this side. I also know that this angle is congruent to this angle. So for the same reasoning, again, these are alternate interiors. I know that this side is parallel to this side. So that is the definition of a parallelogram. It's a quadrilateral with two pairs of parallel sides. Okay, I would like you to take a look at this problem here, where Kennedy has listed all the pairs of congruent triangles that she finds in this quadrilateral ABCD. So pause the video and think about the responses to these questions. Is Kennedy's justification for the triangle congruence correct for each pair? And then did she overlook any pairs of congruent triangles? So go ahead and pause the video and take a look at that. When you're done, come back and we'll compare. Okay, let's see what you have. So yes, her triangle congruence is correct, but she did miss some pairs. Okay, so you can pause the video again and see if you came up with the same missing pairs. Okay, for example 1, exploring the opposite sides of parallelograms. So how do the lengths of opposite sides of a parallelogram compare to each other? So we have diagonal BD, which is a transversal. We have alternate interior angles. BD is congruent to itself by the reflexive property. So we know that triangle ABD is congruent to triangle CBD by ASA. Therefore, by CPCTC, we know that we have opposite sides that are congruent. So, knowing that, what is the length of YZ? Well, YZ is opposite XW, so we know that the length is 3.27. Okay, so that brings us to theorem 6.7, which states that if a quadrilateral is a parallelogram, then its opposite sides are congruent. So go ahead and try example 2. Find the value of x, and then determine the length of each side of the quadrilateral. Pause the video and take a minute to go ahead and do that. Okay, so I'm going to move along here. We're going to go over that problem a little later. Example 3, so we're exploring the angle measures in a parallelogram. So how are consecutive angles in a parallelogram related? So you can use what you know about angle relationships formed when parallel lines are cut by a transversal. Okay, so think about that, pause the video, and think about how are consecutive angles related, and how about the opposite angles as well. Take a minute to think about it, and then come back when you're done. Okay, for consecutive angles, they share a common side. Okay, angles 1 and 2 are consecutive interiors, and we know that they are supplementary. Excuse me. For opposite angles, we can use our congruent supplements theorem. Since angles 1 and 3 are both supplementary to angle 2, we know that 1 and 3 are congruent. So it turns out that opposite angles have the same measure. So knowing that, go ahead and try example 3. Find the measures of angles A and C. And then come back when you're done. Pause the video and come back. Okay, we're going to go over the solutions to this one a little later on as well. Okay, so let me keep going here. So theorem 6.8, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. And theorem 6.9 states that if a quadrilateral is a parallelogram, then opposite angles are congruent. So using the angles of a parallelogram, so the green shape of the fabric is a parallelogram. And the measure of angle 2 is twice the measure of angle 1. What are the measures of angles 1, 2, and 3? So I'd like you to try this example and also these try-its. Pause the video, find the values of the variables and the angles, and come back when you're done. Okay, let's start with this one. So first we know that angles 1 and 2 are supplementary because they're consecutive angles, which makes the measure of angle 1 equal to 60. Because remember, angle 2 is twice the measure of angle 1. Angle 2 is therefore 120. And angle 3 is congruent to angle 2, so it's also 120. From this example, the value of A is 20, and the value of, or the answers for B, well, you can read them off by yourself. If you have any questions about these, you can certainly ask in class. Example 5, exploring the diagonals of a parallelogram. So how are the diagonals of a parallelogram related? So AC and BD are the two diagonals of this parallelogram. We're given that ABCD is a parallelogram, and we're asked to prove that AQ is congruent to CQ and BQ is congruent to DQ. So go ahead and pause the video. See if you can come up with a plan for a proof and write the proof out. You can do whatever style you want and then come back when you're done. Okay, let's see what you have here. Okay, so we're given that ABCD is a parallelogram, which that tells us that AB is parallel to DC by definition of a parallelogram. AB is congruent to DC, theorem 6.7. The fact that we have parallels gives us alternate interior angles that are congruent. We can therefore say the triangles are congruent by ASA. Then we have corresponding parts that are congruent. And that leads us to the end of the proof, where we can say that the diagonals do bisect each other, and that's by definition of a segment bisector. So theorem 6.10 says if a quadrilateral is a parallelogram, then its diagonals bisect each other. So try example 5. Okay, we have a parallelogram. You're asked to figure out the length of SK and RT. So go ahead and try that, pause the video, and come back when you're done. Okay, so hopefully you got 17.5 for SK and 38 for RT. Example 6, Find unknown lengths in a parallelogram. So read through this example, give it a try, and I'd also like you to try this try it. Pause the video again, and when you're done, come back and we'll compare. Okay, so this one we're going to go over a little later. This one, hopefully you got GP is equal to 6. So that brings us to the concept summary. Okay, so there's a lot of different properties that you learned about parallelograms here today. Consecutive angles, remember, are supplementary. Opposite angles are congruent. Opposite sides are congruent. And the diagonals bisect each other. And remember, by definition, we know opposite sides are parallel. So that concludes lesson 6.3. I hope you enjoyed it and have a good day.